Okay, so yeah, integrating the EDS with the cmake. So as part of the electronic data sheets, you can specify all of your APIDs for your various subsystems in an electronic data sheet. So for every app, you can associate an APID with it, and that's all done through the electronic data sheet XML schema. These are mission-wide, so that every CPU, every application sees the same numbers, and the dependency again is all generated by the cmake. When you run the cmake tool, it builds all those dependencies into the make files, and all of the actual C header files that applications can include are generated by the tools. The tools can also output any number of other formats based on the same input. So the EDS file is intended to be kind of this baseline authoritative definition of your data structures, and from that you can derive any other format of your choice. So all of the tools today are generating a C header file. It is fairly extensible, so you can generate any other output as needed. So ITOS files, assist, the Cosmos, XTCE. There's ongoing efforts to extend these tools to have other format outputs as well. And the other, pretty much anything that you need to apply at the mission level or even at the platform level can be defined in these files. And the other note here is the performance IDs. So that those can also be defined in an EDS and therefore shared among the ground and the flight code, as well as all the applications. Next slide. Is that the end, or is there more?
I think that's it. Yeah.
Okay. So
any questions for Joe? Of course, he won't hear that question for 30 seconds.
Yeah.
I've actually got one question. Joe, this is Dave McComas Goddard.
Hi.
Hi. That was quick.
That's
this
it.
mic has.
Oh, that's on the.
And it's actually for both you and Jonathan. So is there an effort to standardize the packet names for CCSDS packets in EDS? I mean, you can use EDS, it's just a dialog.
What do you mean packet name?
Well, not packet, I'm sorry, packet fields. So a standard CCSDS packet, is there?
It's already laid out that way.
That's
There's already a
so
CCSDS.xml EDS.
Okay, and that's part of the standard from the CCSDS world? Or?
Yeah, well, right.
Okay.
But it's our EDS version of that. It's just how the fields are laid out.
Okay. And is that something? Well, that's what I'm getting at. Is so the root of all our ITOS, Assistant Cosmos, all have the same field name because we've standardized upstream. All the.
Yeah, there's
that's a good point, and so I want to get to the more general point. Well, maybe we'll delay that until we talk about EDSs in general.
Okay.
But it's like the EDS is the software version of the world, the flight software version of it. It can be imported into many other things, but there will be some conversions. Flight software doesn't have a concept of a mnemonic. We got these long names, right? Flight software names. The mapping of a mnemonic to that flight software name is a ground system mission thing because they don't like our names. And they make up their own names. You know, this value for this voltage has some very specific meaning, and meaning in the power subsystem guys will come up with. So there's a lot of stuff like that gets folded in there. So the assumption is there would be an associated XML file, EDS thing that can be ingested into tool chains, and then do these kinds of mapping. Some of those are going to be mission specific. Some of the CCD tool, JSC's tool would probably be able to do those conversions. Take the EDS, do whatever magic it is to output what they need. I don't think we need to standardize that because missions like to play that game.
I would think for the primary header.
For a primary header, the names, I don't know that CCSDS actually has, like the APID is a field. So, and I think in those cases, Joe can answer this, it's whether we follow that same naming convention from the actual spec. That's the root of your question.
Right.
I would hope so. If not, we can make it so, because there's no reason not to.
I was going to point out two features of the EDS that help us out here. First of all, it's namespaces. So the electronic data sheet format has an architecture that allows you to put your own stuff in your own namespace, so that things won't conflict, even if you happen to choose the same name. The other thing is, for any field, you can add a custom semantics tag on it that can describe things like usages and units and all sorts of additional details that help keep, because nobody's going to agree on the same names for everything. We've had that problem. It's very difficult to get everyone to agree to call something by the same name across the board. So as the next best thing, we can provide solid mappings and say this name, this thing, this has this name, but alternatively, it's also referred to by these other names in other places. So we can keep that all straight.
Okay, thanks.
Okay. So I think we're going to we're going to do Charles after I do the EDS, since it's a good segue, and then get Charles stuff in. But one thing, being a simple engineer that I am, I like this all the APIDs are one file. There's not like going around and looking and making sure that they're all unique and editing 20 different header files to make sure everything's right. They're all this one file, and it's totally arbitrary. They just can't collide in the XML. It's got the identifier and then the number, and the identifier and number, and then that can be a 16-bit number or a 2 to the 32nd number. And the idea is that the tool still works fine for those as well. But it makes it easy to deploy, and that's why it'd be nice for the performance IDs as well, because they have to be globally unique or system-wide unique. And managing those is a similar problem. Make sure there's no collisions. And that's all manual now, except for maybe with the CCD.
Yeah,
some tools.
The tool will tell you if you have a collision in your app IDs.
Oh, so that's already built into the tool to guarantee that. Because bad things happen when they collide, and you build the system and you wonder what's going on. Okay, Joey, you can stay online, and maybe if some EDS questions come up, since you're one of the authors of our tools, that would be good.
Yep, I'll stay on.
So we introduced this concept last time, and we've matured it considerably since then. So I just want a quick refresher on the definition. So electronic data sheets are a machine-readable definition of software component or hardware device interface specification. And they're different than an ICD is because this defines what the device or software can do. It's not how you're going to use it or what parameters you're using. Because a lot of devices have a lot more things than actually get used for your mission, or even software component. There may be some debug packets or something like that. They're all captured in EDS, but not necessarily how you're going to use them, or what are the limits for your system. Those kind of things which are in EDS may get changed for a mission. For NASA, we've focused on the software interfaces. Actually, this is true for the EDSs in general. We've focused on software interfaces, but they can also have mechanical and thermal and other interfaces. And some of we threw this out to industry, like the Boeings and the Lockheeds all said, well, we want to get that kind of stuff in there as well. What are the mechanical specifications for this device? What are the thermal ranges that it allows? And things like that. Where do you put that thermocouple or something? So they want to see that incorporated so you can bring it into a tool chain and then sort of do a virtual integration of the system. So we didn't address those. And they would be subsections in an EDS, but we're not actively working those. Excuse me. To give some credit, which a lot of credit is deserved here, AFRL, the Air Force Research Lab, about 10 years ago, or maybe even further, developed something they call XTEDs, which is extendable electronic data sheets. It was an XML, and it was for their spacecraft plug-and-play architecture, which they called SPA at the time. What they wanted to do is actually build a spacecraft in 7 days And so without all this automation, you're not going to magically be able to do that. Totally plug and play with sockets on some generic spacecraft. The long-term goal is that all the software and hardware components will come with an EDS. So you get a star tracker, has an EDS. You get a gyro, has an EDS. You know, that means industry's got to come into play. And actually, our colleagues at ESA are working. They're funding some of those efforts to bring in their vendors. They're having a study to actually look at that, how they can apply that. For CFS, you know, I was focused on solving the problem we have now, which is the packet definitions at the messaging layer. And we've made great strides in that area, and then ESA's made great strides at the device level, and I'll get into that a little further. What we're looking for long term is the automation of component integration. So I'll go to the next chart and you can see where I guess this is where we're at now. So this CCSDS working group, the Spacecraft Onboard Interface Services Working Group, or I'm the working chair, has been working to standardize an XML schema and a dictionary of terms for use in defining software and device interfaces. And for people that have heard XTCE, it's based on that, but XTCE is trying to solve everything, way too much. So our focus is much more narrow and therefore and much simpler. So we are much more restricted. There's not 20 ways to do the same thing. There's one way to be able to specify something. Makes it easier for tools to interpret. Where the documents stand now, so the important one is there's a blue book, which means it's actually a standard. And we've gotten all the RIDs back. Several NASA centers looked at it, the ESA folks, the Chinese Space Agency, the Russians. There was feedback from all these agencies, part of the normal CCSDS review process. And we've incorporated those into the books. So the next thing we need to do is actually have a test. For it to be a standard, you have to have an interoperability test. And we haven't done that part yet, but we've got the standard out there. It's available on the CCSDS website. And then we have a magenta book, which is for the dictionary of terms. So the common terms you use in an EDS, you want to have a standard definition for those so they can be used and interpreted appropriately. That's going to be a living document because folks like a star tracker, and they want to add star tracker terms in there, or gyro terms or something like that. And we don't have the domain expertise to be able to populate those areas. So we're just dealing with the software type interfaces at this point, and those things are in the dictionary terms. Things like what is 1553, what is spacewire, those have meaning. So you can call those out in an EDS and say, oh, well, you're following the spacewire spec as far as how the device interacts. Or 1553 subaddress has a real meaning in that protocol. So those are defined in the dictionary of terms. So you can use them in your data sheet. Say this device talks on 5053, uses subaddress 25 and sends this many words, and here's the formats of those. There's a green book, which is this, how do you use this, the data sheets, the dictionary of terms, the overview and rationale. We need to do some work on that because we got to add user's guide type information in there. So how do you use the data sheets? That seems to be lacking at this point. We have what we intended, but we want to bring up actual real use cases. I don't show them here, but there's two other books, which are orange books in CCSDS terms, which are just informational. The Chinese Space Agency has created one that brings in these terms and shows how they apply it to their architecture. And I'm supposed to be working, it's been approved, but I just get the time to do one for CFS. So how do we apply data sheets to CFS? Which is sort of very helpful from a user's guide perspective. So here's the big picture of what you're trying to do with an EDS. So software components and device components, you can bring the data sheets into designer tools. You can generate flight software components. You can generate model interfaces. For test and simulation, you can generate test code and build simulators based on EDS. EDSs have state machines associated with it. You send a command to it, and you expect some sort of response back, and those things can be encoded into the EDS. So you can actually get a functional level interface and auto-generate that from an EDS. Nobody's built that tool yet, but it's an area that we intend in the future, because it's very powerful to be able to drive your tool chains with this definition of what your interfaces are. Ground systems, things that it's kind of obvious, this ground system databases and ops procedures and those kind of things can be driven from EDS. If the EDS has a state machine, you can drive a ops procedure from that. Send this command, you expect this kind of response with this kind of timing associated with it. And what do you do in a failure case and those kind of things. So, this is sort of the grand scheme, but this is all the places you can go with it. We've done a couple of them, and what Joe Hickey was talking about earlier with the cmake, we've done the flight software component part. ESA's done the flight software component part at the device level, and I'll talk a little bit about that. They actually took a electronic data sheet from one of the vendors that does a Jenna star tracker. And I'll get into a little bit more details a little later, and auto-generated the code to interface to that. That's pretty powerful. This is, I want to make clear, EDS, it builds. If you get a star tracker and it has an EDS, it doesn't necessarily tell you what your software message is going to be. So your software message, which may have other information like what's this temperature sensor that somebody glued to the side of your star tracker say. So it's all in one packet. So you pull in the star tracker EDS, you add it to the thermal EDS, and then you build the software packet, which then goes into the spacecraft database. So they sort of build. You can import a lower level one into a higher level one, and then add and combine packets and stuff like that. Ultimately, you're ending up with the ground system database, which is like the EDS for the spacecraft, in XTCE. We're not trying to go there as far as defining what that format is, but that's the end goal, starting from a device and working all the way up the stack. But you're allowed to keep the packet formats, and the engineering unit conversions, which came from the manufacturer. You don't get to change those. So anyway, one EDS can feed in another, and this is all tool chain driven. We don't have all that stuff yet, but that's the long-term goal. So here's the current status. So, as Joe was just getting, we're integrating the EDS into the CFS build system. I think, I got it should be 6.6 in mid 17 calendar year, or whenever Susie says that's going to be released. We had some extra money, so we got a prototype tool to take an EDS and generate XTCE, and then import that into Cosmos. Same person that did that said I did some side and have some ITOS and assist tools as well. They're not that mature yet. This is a prototyping effort, but long term is you want to have this end-to-end tool chain, in a certified tool chain, that you can guarantee that it works. So it needs to be move out of prototype and into production as far as the tools are concerned. ESA has developed a tool to generate the flight software for hardware devices, and they demonstrated that for this Jenna star tracker that I was talking about. And importantly, as just confirmed by our ESA, one of our ESA representatives here, they're putting over €1 million into maturing the EDS concept. That's serious money. Especially, so if their vendor, say the Star Tracker, wants to sell that Star Tracker to a U.S. company, and here's the data sheet, it makes it easier to integrate that and purchase that device. So it goes back both ways. And there's a lot more tooling that they would be interested in. Did you want to speak to that?
So maybe I should just comment on that. My name is Marianne, I'm from the European Space Agency, and I'm responsible for exactly that activity to mature the EDS. So my name is Maria Hanek, I'm from the European Space Agency, and exactly what Jonathan says, I'm responsible for that specific activity. And we have seen a major interest among our primes to actually support the sort of the improvement and the maturity of the electronic data sheet. However, we address it a little bit from the other angle than what you're doing now. So we will more look at the other stakeholders that are outside of the software business. So in principle, the supplier. So the supplier on one side and the AIT needs on the other side. Because I mean, the major benefit of the EDS is the machine readable concept, and that actually you can ensure that you have just one source of data. So that is sort of risk with duplication of data, and that you actually get the wrong data will be limited. So I think that we take an overall concept of the whole system development, where we bring in EDS, and not only for the software, but for many other of the aspects. So 1.1 million there, yeah, it's a lot of money, but I think on the long run, we will actually need more money.
Yeah, thank you for that. So this is going to happen because there's a lot of interest, and when industry gets interested, and that's one of the things that's going over well. So the Chinese Space Agency is also working to develop tools along these lines because they have a software architecture that actually follows the CCSDS SOIS stack. It's very similar to CFS, but it's not. And I don't think they'll be open sourcing that, but it's going on their next generation space station. But they're very interested in the EDS concept as well, because the nature of space stations, it is really somewhat of a plug and play. You bring new experiments up and you plug them into the network and stuff like that. So that they have a big interest there as well, and they're putting some money behind it. I want to note that there's a lot of CFS users that have created database tools. We've seen that this has been replicated just about everywhere. Even in industry, I've seen similar things. Is everybody's sort of coming up, how do you manage the data? And I know Ames has some JSON tools that sort of had this functionality, but maybe not. I don't know. You don't know? Okay. Well, I've heard that, and they have their own JSON EDS thing going on, database for all the packets that go back and forth and parameters and such. So I guess in the end, as was pointed out earlier, we want the EDS to be used as the source files for these tools. So you don't have to use them throughout. You can still have your CCDD tool, command and data dictionaries, and but you use this as a source, because when you pull it out of Git, you'll get that with it. And then you can integrate easier. If you write a new app, we'd like to see an EDS come with it so it's easy to integrate into the tool chain. Oops. So I guess now, any questions on that? And then we get into the next set of slides, the unit test framework, Charles Zogby. Good.
Thanks, Jonathan.
Wait, did you have a question?
Thanks, Joe.
Oh, yes, thanks, Joe.
No problem. Thank you.
So you want me to? Yeah, which one is it? Yeah. Well, you can find it. Okay, thanks. And you can, that's